Hi. So in this video, I want to talk about the subplot command in MATLAB. Previously, we talked about plotting and we talked about figures. And in my introductory video to plotting, what we would do is set up some X matrix of whatever values you want, some Y matrix of some corresponding values. I don't know, I'm just doing random things here. These matrices have to be the same size in order to plot them. In this case, I did 4 numbers. And if I plot that, it'll show up in a figure like this. I'll go ahead and dock that figure. And then we talked about holding on, where I would set up some new type of thing. I'll go from 0 to 10 in increments of 0.001. I will say that this is the log of x. This is the natural log of x. I plot x and y. Well, natural log of x won't work for 0. Let's say I do it from 0.001 onwards. That's going to be a disaster, actually. Let's just do it from like 2 to 4 or something like that in increments of 0.001. I'm holding on, meaning that this figure will have the state of being held, meaning that anything I plot after this first plot will be laid on top of this and not overwrite it. If I run this, you can see here's my logarithmic graph from 2 to 4. It doesn't matter that these axis limits are from 0 to 10. We'll talk more about what this is, how to change things like that, the axis limits and stuff in our customization video, if you want to go check that out. But what if I want to plot these two graphs, but not on the same? Oh, there's my dog. Hi, dog. Let me come here. My dog's in the room. That's Lloyd. You see him on the bottom left of the camera. What if I wanted to plot these not on the same set of axes, but I wanted to plot them in two separate sets? So instead of plotting on same axes, plot on two other or multiple axes nearby. Let me get my dog out of the room. All right, you can leave. Come on, buddy. Let's go. Thank you. So, and this is where the idea of subplots comes in. So a subplot is set up where you will specify in this command where you want your plot to be. So before I go ahead and actually write this out, I want to do a little bit of not a figure, but I'll do a little illustration here. Where basically the way that it works is kind of like reading from left to right and then skipping a line. Is that if I had, let's say, 2 rows of graphs and 3 columns of graphs, our graphs are labeled in order 1, 2, 3, 4, 5, 6. We read from left to right, and then we read from top down, just like we would in English. And the reason I'm mentioning this is that you will specify the arrangement of how you want your subplots to be, how many rows and columns, and you will specify which graph you are now going to be plotting on. So for example, let's say I do subplot of, let's say I do 2 rows, 1 column, and I'll do 2 graphs just as an introductory thing. So with that in mind, we'll have 2 rows and 1 column. So this will be graph 1 and graph 2. Oh, I shouldn't do this yet. This is saying row 1, or there's 2 rows, 1 column, and then I'm going to turn on the graph that I want to plot. So let's say I do this like that. This is going to be, the general format is rows, columns, graph you care about. And then let's say I take, x equal to 0 to, we'll use the same examples from earlier. We'll do these. So by writing this line, it basically says that your active graph is going to be the one that is in that position in this matrix that is arranged. So if we plot this, you will see that now I've created a figure where I have this giant blank space down here, which is the second row of a matrix, basically, where this is in the first row of this column. Excuse me. So this is in the first row of that column. Now, if I want to go ahead and plot the other thing, first off, I can still do the hold on thing like I did before. And this will still be related to this figure that I've chosen, this subplot here. So if I run this, say just run this section so I don't replot the other thing, you see that it ends up plotting on that first figure because I've held on that figure. But maybe what I want to do instead is plot this red line on a different graph, this logarithmic function that I arbitrarily chose. So what I will do is I will say subplot. I still want the same matrix arrangement. So I'll say 2 rows, 1 column, and then the figure that I want to mess with is the second one. Because again, we're reading from left to right and to down. There is no left and right motion because it's just 1 column. So this is the second graph that's in our list. So let's go ahead and we'll clear the figure. So now if we do this, we see, oh, here is our first graph, which has an x-axis from 0 to 10, because that's what this x spans from, 0, 10. And then the subplot, you'll notice that the x-axis is from 2 to 4. So even though our axes are different, they are basically just completely separate plots that just happen to be shown in the same figure window with the subplot command. So I'm going to do an example. Let's go ahead and clear the figure. Where let's say I want to plot a graph, and then I want to plot the area under that graph as well as a function of position. So let's say I want to plot y is equal to x squared, and also plot the area from up to x. So basically, as I move from left to right on my axis, I will look at how much area I've accumulated up until that point. Well, first off, how do we find the area expression of y equals x squared? Well, we would integrate it from 0 to x, whatever that x is. So the area, if we integrate that, we'll add 1 to the exponent to make it x cubed and divide by the new exponent. This would be 1/3 times x cubed. So if I am at x is equal to 0, I haven't accumulated any area yet. If I've gone to x is equal to 1, that means that I've accumulated 1/3 as my total area. And if I go up to 10, 10 cubed is 1,000 divided by 3. That's like 333. That's how much area I would have under my quadratic if I went all the way up to that higher x value. So that's what I want to show. And what I'm going to do is create a matrix X, and I'll go ahead and use linspace. So I made a video on linspace. Go watch that if you're unsure about what this looks like. And I'll do linspace just because arbitrarily, let's say I want specifically 1,000 points. And maybe I'll go from the start number being 0, the final number being 5 with 1,000 points. Just to remind you, if I do this, you'll see that it is incrementing by some constant amount that MATLAB would find. It looks like it's 0.05 between these next two numbers. And it'll be a full list that goes from 0 all the way to 5. And it'll find the appropriate increment to make sure that this occurs with equal spacing between the points. I'll then say that y is x squared, which we know we could square a matrix using that, the dot operator. You could also do a loop of some sort if you wanted to, but this is definitely the simplest way of doing this, because we're going to square that matrix element by element. If you do this now and let this come up in the command window, you'll see that our final point has to be 25. So if we run that, we see that our final point is 25. And all the other points are the squares of their corresponding x values. So x squared is 0, 0.005 squared is whatever, 0.1 squared is whatever, and 0.01 squared is whatever, and so on. So just going ahead and square every value in that matrix. So our first thought is plot the quadratic, and maybe that will be in our upper section of our thing. So maybe now we'll do it like that still. So I still want to do the subplot of with 2 rows, 1 column, and I will say I want to mess with graph 1. And what I'll do is I'll plot x and y. And if I do this, we see that here is our quadratic from x is equal to 0, from x is equal to 5. And it'll plot the quadratic. We see at the top it's at 25 because we're squaring that. And then everything in between with all of our points that we've used, we end up having this nice smooth curve. Now, somebody might be reading this and say, what is the area up until a certain point x? Well, let's go ahead and plot something in the graph below, which is the second graph in our list. And I'll define my area as 1/3 times x cubed, where again, I have to include the dot here to cube every element inside of this matrix. And I will plot x versus the area. And this will be plotted down here. So I go ahead and plot this. We see that as we go to some arbitrary point x, let's say I'm at x is equal to 2, I can see what the area is at that point. It ends up being, some arbitrary value. Another thing cool about MATLAB is that if you zoom in to your graph, assuming you have the updated MATLAB, you can go ahead and go to that area to get a feel for it. Now note that because we did linspace, we may not land exactly on 2. And if you look, I'm just going back and forth between the values. I don't ever land on 2 because I'm adding 0.005 in between the increments. But this is basically saying that if I were to integrate this graph x squared from 0 to 2, my area would be 2.67. I can zoom back out if I want. There's my graph. I can bring this all the way up here. If I were to integrate from 0 to 5, the total area under that graph would be 41.6667, which is 5 cubed over 3, 125 over 3 ends up being that value. This is the idea of subplots. Let me do one more example, a short example, kind of with something like this, where we have multiple graphs. Let's say we do a 2x2. Again, if I do a 2x2 matrix, we read from left to right. This is 1, 2, 3, 4. And these numbers, the 1, 2, 3, 4, are corresponding to the graphs that we want to plot on. So for example, I don't need to plot these in order. Let's say I want 2 rows, 2 columns, and I want to mess with graph 3. And I plot, I don't know, a line. Just doing this randomly. So what will pop up? Well, I've said I want a 2x2 matrix, so we'll see 4 figures here. Well, not yet, but we will see 4 figures. And I am currently working on the 3rd figure in our list, which if we read from left to right will be figure 1, figure 2, figure 3 or plot 3, and then 4 is to the right. So if I do this, we'll see that this plot, oops. The reason why this is happening is because I was still plotting the other stuff. Let's come to here and just run this section. We'll see that it's down here. So I can do 2, 2, 2, let's say. And I plot something weird. 2, 3, 3, 3. If I ever have something like 3, 3 in my y values, what would that look like, do you think? I'm plotting the point 2, 3. I'll change this to a 4. And 4, 3. What does that look like? Well, let's see. We already know that the 3rd graph is this thing. If I plot this now, it'll come up in the 2nd graph. It's a horizontal line. I can now go to subplot 224 if I want and do plot. Let's say I keep the x values the same, and then I change the y values. Same logic here. If the x values are the same, I have x equals 1 and then x equals 1. That has to be a vertical line. So if I run this, we'll see that graph 4, which is this guy, is a vertical line. And lastly, we'll just fill in the graph, plot. Maybe we'll do something a little bit different. Let's do that. I plotted the kind of the opposite of this. And just by doing these 4 things individually and telling MATLAB which plot I'm messing with, it will edit that plot. So you can go check out my customization video where we talk about how to edit figures. But for example, if I were to come down here and do subplot 224 and say X label for figure 4, what will happen? Well, you're telling MATLAB, I want you to focus on this subplot, which would be this one, and I want you to make the X label this thing, X label for figure 4. If I run this, you'll see that the X label ends up being down there because I told it to be figure 4. Now, if you want to be real fancy, let's say we do something like this. Subplot of 22II. Let's see what we can understand what's happening here. So let me clear this. Again, I'm just doing this as a random example. I can have this in my code, for instance. This is saying that I want to create my 2x2 matrix, and I'll go in order from graph 1 to graph 4 and do the X labels. And, just to kind of show this happening in real time, I'll pause it for 2 seconds in between. So this first 4 will end up plotting the graphs individually. Then we'll come here. No, maybe we'll pause it for 2 seconds after each so we can watch this fill up again. I'm just pausing to show something. So let's go ahead and look. So we plotted the 3rd graph. We've plotted the 2nd graph. We've plotted the 4th graph. We've plotted the 1st graph. And now we're going to go to the 1st graph, plot it, pause. 2nd graph, plot it. I did figure 4. I probably should have changed that, but so be it. And it's just creating those one at a time, because every time I change the subplot command, it'll go ahead and turn on a certain plot that we're editing at that point in time. Now, if I were to do Y label at this instance, the Y label, which graph would it edit? Well, it'll edit the one that we are currently active on. And based on our code and how we did it, we're currently active on figure 4 because II ended at 4. So if I do this, we'll see the Y-axis here show up. I don't want to deal with the pausing again. I do that, it shows up over there. So I hope that this makes sense. Just remember that we read from left to right and we read from top to bottom. So if you ever end up with some weird amount of graphs or something, 6, 7, 8, 9, 10, it'll just read from left to right. And whichever one you want to mess with, well, you have to make sure that you make that one active by doing subplot. In this case, I have 3 rows, 5 columns, and I'll pick figure 9 randomly. It will go ahead and go and edit this. Let's actually see what this looks like. I'm just so curious. Plot 1, 2. It's going to be really tiny in my window. Yeah, there it is. That's the 9th one. We can see that it's right here, the 9th one. So I'm going to have 3 rows and 5 figures across. That's pretty neat, depending on what you want to share with people or publish about or something like that, this type of information. So I hope this was helpful. If you have any questions, please let me know. Okay. Thanks, guys, so much. Bye.